Okay, Magandang Maga algebraists. Today we're going to continue on. Yesterday we knocked out 1.1. Moving on, today we're going to look at 1.2, and our focus is going to still be on nice, easy linear stuff. But we're going to take a step away from equations, and instead we're going to work on linear inequalities. So solving linear inequalities is what we're going to roll with today. Now, right off the bat, linear is not like a terribly long word, but inequality is long and it shows up a lot. You will see me use lin inequa. This is my shorthand, not accepted in the math world, just my shorthand for linear inequalities or inequalities in general. Cool. So, to kind of get us started here, our first little topic of today is going to be on one-step inequalities. And I'm going to jump right into that shorthand. One-step inequalities. And right off the bat, there's a little bit of notation that we're going to see that some people struggle with. And I've seen people struggle with it all the way through high school, even up to calculus. I get it. It's weird. But I just want to really quick recall, because these are things that we have seen before. We want to access all that prior knowledge. If I want to compare 5 and 5, what's a symbol that would go between them? They're both 5, so what's the symbol between them? Equal, right? So we can have some quantity be equal to another. So A equals B is common, right? We've dealt with that one all the time. Is it possible that those two numbers aren't the same? Yeah. Is it possible that A was larger? How would I write that mathematically? Okay, so I heard A is greater than B. I'm going to put A and B here. How do I remember which one means A is larger or greater than? Hey, I like it. The crocodile is eating A, right? A is greater than B. Now, I could flip that around as well, though, right? I could also have that A happen to be smaller than B instead. In that case, we would say A is, what's the real language we use? Less than B. Okay. We're going to be dealing with simple inequalities in this form. And it's really important to note, I'm going to make this comment in blue. You can write it down if you would like. Could I move the order of these and still have it say the same thing? A is greater than B is the same thing as saying B is what than A? B is less than A. Now, these two comments are equivalent. They mean the exact same thing. Notice the alligator is still eating A. It's going for the larger piece of food. All right. If you mess those up, I'll call you out on it. We're going to make sure we fix it. Cool. So we're going to jump right into some properties with these guys. So properties of inequalities. Properties of inequality. Which yesterday we dealt with all the properties of equality, so we're just expanding that and going a little bit further here. Now, like we did yesterday, we're going to set it up similarly. If I know for a fact that A is less than B, what happens if I add some number to each side? So let me work that out. We're going to do addition/subtraction. Here's one of my properties. And I think we're going to sneak in a little bit of symbolic logic stuff here, just to kind of save us some time with notation as we move forward. I'm going to say, and I'll write this statement two ways. If, let's say we have A is greater than B, if I were to add or subtract the same number from each side, and I'll even work like a concrete example simultaneously. 6 is greater than 5, I think. What if I did 6 plus 2 and compared it to 5 plus 2 now? They're the same, right? It stayed the same. So we're just going to make sure that we have our addition and subtraction. Would it have worked if instead of adding 2 to each side, I subtracted it? Yeah, it's still the same. So I'm going to say if A is greater than B, then A plus C, or minus, so A plus or minus C, is still greater than B plus or minus C. Okay, nothing too crazy going on here. I do want to talk real quick, just logic-wise. If then, have you guys ever seen that in math before? Yeah, it happens all the time, right? So we do have a shorthand, and those of you that have taken geometry have seen this. I just want to make this clear to everybody who maybe hasn't seen it in geometry yet. If I wanted to shorthand this, it'd be A is greater than B. I'm going to put that in parentheses just so I can clearly see that that's the first part of my argument. And anybody remember the sign that we use to say then? I like it. Pia used her hands to show me this double arrow. The implication. If A is greater than B, then, or this implies that A plus or minus C is greater than B plus or minus C. Okay. Addition, subtraction, nothing too crazy. What else did we do? Properties we saw yesterday, we saw we can add or subtract, and what else did we deal with? Multiplication and division. So, we're going to do multiplication and division as well, but we're going to need two little different categories here. So, this is going to look a little tiny bit different, but I'm going to do two different cases. What's weird about inequalities in multiplication and division? Do you guys recall? Negatives get wonky, don't they? What happens if there's a negative? The sign, the direction of the inequality switches, right? So, let's check this out. The first case, case 1, if C is positive. Okay, is there a more mathy way to say that rather than writing out the sentence? Maybe using even inequalities. How would you say a number is positive compared to some other quantity? Let me rephrase this. A number is guaranteed to be positive if it's greater than 0. So check it out. If C is positive, we could concisely write this. C is greater than 0. All right. If C is greater than 0, and I were to tell you that A is greater than B, if I multiply by C, does my inequality change? If C is a positive number? No, it's going to stay the same. So we'll say AC is still greater than BC. What about division? If we bounce over here and do an actual example, let's say 10, we'll do 15, is greater than 10. If I divide each side by 5, is it still true? Yeah, I can see that it's still going to work. So we'll go ahead and sneak that in. A over C is still greater than B over C. But all of a sudden, alarm bells are going off in my head. Yesterday, we had to add a little follow-up comment, a caveat to this sort of operation. What do I have to require is true about that value C in the case for division? It can't be 0, right? So we're going to go ahead and add that in here, where we ensure that C is not equal to 0. All right, we've knocked out the positive case. Give you guys a second because I still see people writing. Again, I really need you guys to help me if I'm going too fast and writing too fast. Tell me. Cool. All right. Well, we have two possibilities. C is positive or negative. So we'll go ahead and write it out the same way. If C is negative, which mathematically, just concisely, how can I write that, Miguel? Negative number is always what? You're right. How do we write positive up above? Greater than what? So to say a number is positive, we just say it's greater than 0, right?
Yeah.
How could I do that for a negative number?
It's less than.
Perfect. So if C is less than 0, and let's check this out. If A is greater than B, then when we compare AC and BC, think about what happens. 3 is greater than 2. Give me a negative number to multiply each side by, Pia. Multiply each side by some negative. Pick a negative number. So we'll multiply everything here by -2. I would have -6 and -4. Which one's greater? -4. And this is always a weird concept because when we talk about greater, remember, we really mean which one's further right on the number line. -4. Gosh, that inequality sign flipped. We want to make sure that every time, if we multiply by a negative, this does in fact happen. Okay, real easy to forget. Super easy to forget. If you show all your work and that's the one mistake you made, you'll still get partial credit, but I'm going to stress, try our best to remember that. Does the same thing happen with division? It better. Multiplication and division are like the same thing. So we'll still see that if A is greater than B, then A divided by C becomes less than B divided by C. What caveat do you want me to add there, Twan? What little comment do you think I should make when I talk about division? Specifically, division by C. What can't I ever divide by? 0. So let's go ahead and say that. C, whatever I'm dividing by, cannot be equal to 0. All right. These are our major properties that we're going to deal with right now. We're not going to get too crazy with them yet, but we do need to make a couple little follow-up comments. So outside of multiplication and division, I mean, this just kind of refers to all of these. Comments. We will graph our solutions. Remember, SOLN apostrophe S is my shorthand. We will graph our solutions on a number line. And I'm going to make that a capital and, we will graph our solutions on a number line and cool. We will graph our solutions on a number line and express them in set builder notation. And I'm going to sneak that in as a capital there so its importance is recognized. Set builder notation. Gosh, that sounds really familiar, I hope. You guys recall hearing set builder?
No.
Thumbs up or thumbs down, just so I can kind of get a gauge. Because depending with COVID stuff, you might not have seen it. Okay, set builder is super nice. It makes it really easy to see our answers. We will learn another notation later in the year, but let's talk a little bit about this set builder notation. So I'll even underline that.
Is it the one with golden dots?
So we will deal with that for sure. That'll be another comment. Set builder itself looks ugly the first time we see it. Typically, which variable do you think we're going to be using for our algebra that we're doing, at least for now? X is pretty common, right? So, first thing, we all get to draw these perfect, pretty curly brackets. And these brackets are indicative of a set of numbers, a whole collection of them. So, when we're going through set builder, we will write our answers in the following format. This thing means the set of X, and we use a vertical line for such that. And we'll make sure we write this out as well. Not a 1, a vertical line. The set of X such that X is, we'll just pick a greater than C for this particular example. All right. You may not have remembered the name. Same thing, thumbs up, thumbs down. Have you seen this before? Okay, so some of you have, some of you haven't, and that's okay. We will get practice with it. Just so we're clear, this thing very specifically reads the set of all X. And that's literally just this first part. The set of all X. Such that. That's our vertical bars are such that. And X is greater than C. And we do this for a very particular reason. I'm Miguel, give me a number. Let's say it was x is greater than 4. Give me a number greater than 4.
5.
Is that the only one? No. 6, 7, 8, 9, all the decimals in between, all infinitely many of them. Do you have time to write all the answers? No. What this is telling me is very specifically that, hey, all of your answers are the infinitely many of them that fit this qualification. Any number greater than c will work. 4.0000001 is still greater than 4. All right, last little comment, and then we'll start doing some actual problems. We'll just build them up in difficulty as we go. We all know that we have the three symbols, greater than, less than, or equal to. What happens, however, if I change and make a little bar underneath of it? This now means greater than, but there's more to it. Or equal to. So, greater than or equal to. Which means we will include that number. If it was greater than or equal to 4, I start at 4, and then I start working right on the number line forever. Do you need me to draw the less than or equal to parts as well? Okay. I promise this is the last comment, and we'll just start doing problems. When graphing, and this is going to look nicer in person than it will in your notes, so we'll make sure that our ears are open for this one. If it's greater than or less than, do you remember how we kind of note that on our graph? And Vanessa, this is what you were talking about, I think. Do you remember, Isnardo? What happens?
On the number line.
Yep.
Either circle that specific number and then whichever way the arrow goes, that's where you want.
Okay. Yep, you're perfect with that. I'm really going to pick on one particular part that you said, though. Circle the number means that for greater than or less than, we use an open point to indicate you start here, but don't include this number. Open point. Now, when we compare that PIA with greater than or equal to or less than or equal to, what happens? What changes? I now have my point, and I fill it in. I don't need it to be that big of a circle. Okay, open point if it's greater than or less than, closed point if it's greater than or equal to or less than or equal to. And that'll just help us tell on the graph exactly what we need. All right, so pretty much the rest of what we have here are examples. So let's start running through them. Before we go, questions, anything that I've done, you look at it and go, oh, I don't really get this. I'll feel like you're in 8th grade again. Okay, let's knock them out. So here we go. We'll build up complexity. I want to solve and graph. All right, starting with some easy ones. Let's knock them out. Let's say I want to do, I don't know, let's do r plus 5 is greater than or equal to 7. Legitimately, these problems do not get a whole lot easier. These are our single-step inequalities. And the cool thing about it is mathematically, they act just like equals. The only thing that's going to change is how we express our answer and what our answer really means. So looking at this thing, Alan, you want to solve this inequality, what do? Subtract 5. We're still trying to isolate our variable just as if we're solving. This would leave me with r is greater than or equal to what number, Miguel?
2.
You got it? I don't like the way that looks, so I'm going to fix it. Greater than or equal to 2. Now, if I stop here, technically am I wrong? Should this be our solution? Kind of, right? Now, what's wrong with this? Like, if I just stop here, why am I not going to give you full credit? You're probably going to get a point because your math looks fine. But I'm a real stickler for notation. What do I have to change according to the notes or little comments that we made above? Read through them asterisks. Oh, I need set builder first. And I also have to do what according to this example's name? I need to graph it. So, for this, I like to be really lazy with this. If I am confident in my answer, I will typically just sneak in an R such that and make my set here. If you don't like the way that looks, you are cool to get your nice curly bracket. and it's the set of all r, since that's our variable that we're working with. Then I put this vertical line. Natalie, what does this vertical line mean? Such that, perfect. It's the set of all r such that, what's true about r? What do we find in our actual problem? Greater than or equal to 2. Here is our set builder notation. I'll go ahead and mark it out. And finally, we'll graph it. If you just sneak it in here? Yeah, I'm cool with that. That's what I do, but I'm lazy. Okay, to graph this thing, we get to graph on a number line. If you're sitting there thinking, oh, but I love doing the XY plane and graphing harder stuff, we'll get there. So good news coming. In the past, you might have had teachers that required a lot of points. In all honesty, I only require the points that are part of our solution. So there's only one number here that I'm really worried about. What number is that? 2. I'm going to put 2 on my number line. Now, because it's greater than or equal to, should it be close point? Open point above 2. Close. Let's close it. Close point above 2. Okay, then we just have to do a little bit of thinking. Give me a number greater than 2. 5. Is 5 to the left or the right of this number here, Ramaya? If I were to put 5 on this number line, would it go to the right of 2 or would it go to the left of 2? To the right. So check it out. If I need a number greater than 5, I will indicate that, hey, all these answers are cool with an arrow moving to the right forever and ever. Literally any number there will satisfy this inequality. Super hard, right? Should we try to make it a little more challenging? All right. Let's build it up a little bit here. Okay, so there's our first. Let's say on this one we have 5x minus 3 is less than 4x plus 2. Five x minus 3 is less than 4x plus 2. All right. We are out of one-step land. Luckily, or unluckily, depending on how you view it, we don't have a whole lot of multiplication or division that's going to happen. But looking at this thing, our end goal is still the same. We want all the x's on one side and only x's eventually. Jesse, do you have a gut feeling for what you would do first on this problem? Okay, so you want to move this one? How would you get rid of this 4x on this side? Minus. Yeah, let's subtract 4x from each side of this equation. So here we are. I will subtract 4x from the right side of the inequality and 4x from the left side. Now looking at this, I can see that it's going to spit out 5x minus 4x is how many? Just x. And I still have this minus 3 hanging out. Less than 2. All right. What do you want to do now, Natalie? What do you think? Add 3. We will add 3 to each side of this inequality. We're allowed to do that as long as we're not changing anything too crazy. And we conclude then this statement. X is less than 5. Am I going to get full credit? No, why? Okay, love it. Natalie says not in the notation. I want to know what notation or which notation. Set builder. I'm going to do it the lazy route. I'm going to just make this a set of all x such that, we'll just do it right here in my answer. Anybody's brackets coming out just really ugly? It happens. Okay, to graph this thing, as Nardo, I'm going to make a number line, and which number will I put on the number line? I'm going to put a 5 on my number line. Boom. Okay, first thing I care about, Ramaya, if it is just less than 5, should it be close point or open point? Open, there it is. And Pia, if I want less than 5, which direction would you advise me to push the arrow? To the left. So it looks like anything less than 5 will satisfy. Okay, on simple problems like this, even though they're simple, I would encourage you to check and answer. How would you go about checking? So you say plug it in, but I have an issue with that. How many numbers do I have to pick from to plug in? A lot. How many? Infinitely many of them. Are we going to plug in all infinitely many of them to check? No. Pick something in our solution set all of these numbers that we could pick. What's the easiest number left of 5 that you think you can plug in? Ooh, somebody said it. I heard 1. Not bad. 0? I like 0, Twan. So check it out. If we plug this in, and we're just going to mental math this, if we plug in 0 for x, they're just gone, right? Is it true that negative 3 is less than 2? I'm feeling good about my answer. We're solid. All right. Here's what I want to do. First, I want yellow. Let's bump it up. I'm going to give you a harder problem that I want you guys to do at your desks. I'll work through it afterward and we'll check everything. But talk with one another, talk with yourself. We're going to bump up the difficulty here and see what happens. Ooh. All right. Here we go. 8y. I'm going to claim is greater than or equal to the quotient of negative 5y plus 9 divided by negative 4. Okay, stepped it up in difficulty. Talk with each other, talk with me. We'll see where we're at 60 seconds from now. Chat with each other though, check your answer if you find one. We'll be back. If you're watching this at the airport, pause it now and resume in 3, 2, 1. Homework. For those of you traveling, here are our steps. You can pause it now. So we're going to bounce to homework. Tonight, I want you guys to start working on homework 1.2. I will collect this on Monday. This is on page 17. So be really careful. When you're picking your homework solution or homework problems, get it out of chapter 1, section 2. Homework 1.2 you will find on page 17. You get the privilege this weekend of working problems 11 through 23. Ooh, that must be 29 through 35. Not 25, 35 right there. All odds with the exception of number 40. Now, number 40, it says challenge. Don't trust your book. Whoa, that didn't do what I wanted it to do. Get out of here. There we go. Okay, 11 through 23, 29 through 35, and then do all the odds there. And I want you to try number 40. If you want to put an asterisk next to number 40 so that you know that we have it, I want you to try that. That's the challenge problem in your text. Cool.